because of the time, we need to move forward to the next speaker. So our next speaker is Dr. Lei Zhou from Texas A&M University, also in Geography Department. So we all know that recently the geospatial artificial intelligence brought, powerful tools and methods for us to more intelligently mining the geospatial big data. So Dr. Zhou is going to talk about how we can leverage GeoAI to empower disaster response with social media data. Yeah, sure.
Okay, good afternoon, and thank you so much for the introduction, Dr. Kai. This might be the nicest introduction of me from you over the past 10 years. So I'm flattered. And also, today's session is about the uses and the misuses of social media, which is a very critical topic because, like Dr. Kai mentioned, a lot of people are trying to emphasize how important the data they're using and how much benefit they can receive by using the data set. On the other hand, have we ever thought about the limitations of the data we use, especially considering the amount of research outcomes and practices we have been relying on the use of social media? So in my talk, I definitely will introduce a lot of applications, mostly so-called successful examples about the use of social media, but also will pose some questions, some of the challenges I find extremely important when we think about analyzing social media in the practice. And this is not an individual effort. This is a group effort with the support of all my students and colleagues and many of them in here. So really appreciate your support for joining the lab and contributing to this work. So before getting started, I want to share a few of the natural hazards happened over the past few years. The first one was in 2020 when there was a very devastating wildfire in California, and a lot of people were forced to evacuate because of the wildfire and also damaged many homes in this area. And then the second one is a winter storm Uri in Texas last year, and I personally experienced this disaster. Although my son, he enjoyed the snow and enjoyed the time when we don't have power and he has to watch the laptop and the cartoons on the laptop. But personally, I don't enjoy that because we have like electricity rotation every half an hour. So it was a disaster for me and many people living in Texas who has never experienced the snow for the past over 20 years. And the third one is a flash flooding event in Beichuan, Sichuan in China, happened this year. And because of the flash flood, based on the news, thousands of homes have to be evacuated and within 8 hours, right after the disaster. So the three were supposed to be videos, but due to the limitation of uploading, I have to convert them into the slide, the PDF version. So just imagine those are the movies playing behind, showing the devastating impacts of the disasters. So under disasters, every community, every human beings will act very differently and shows the different patterns of the recovery and the mitigations. So let's take the middle one, the winter storm Uri, as example. This too shows the nighttime light images in the Houston area right after the winter storm and before the winter storm. So the three areas circled by the white rectangles in here, they have very strong nighttime image signals before the event, but shows very low image signals right after the event, while the other communities are already fully recovered or mostly recovered after the disaster. So during those disasters, every community reacted very differently, and very important for us to understand the real-time information to know how people actually respond to disaster. And those information will help us to promote the resiliency of those communities and reduce the damages in future events. So I'm going to skip this slide because I know Rohan has already given a very comprehensive introduction about the benefits of social media because of its easy access, the widespread usage, as well as the real-time functionalities. So basically, we consider social media as a mirror of the real world. Whatever happens, right, like what happened right now, the AutoCarto conference, we can see the traces and the digital footprints of the actual events in the real world on the social media platform. But there are also a lot of challenges, biases, and noises on social media. For example, considering disaster-related social media messages, not every message posted on social media are relevant to disasters, even in the most affected areas. On the other hand, there are also a lot of biases in here. I believe the most popular social media platform in this room might not be the Twitter or Facebook. And especially recently, as Elon Musk purchased Twitter, we have already seen a migration from Twitter to other social media platforms. Like people are posting like we're moving away from Twitter. So everyone has very different biases and preferences towards the social media platforms they like to use and the way they interact with others on social media. That's something we would like to mitigate when we analyze social media and make it useful during disaster events. So in general, there are 3 research questions I would like to propose and try to answer in today's 15 minutes. The first one is how can we extract disaster information from the noisy social media data, meaning the small amount of information from a large amount, 400 million tweets every day. Secondly, can the social media data be used to improve disaster response? Because we have seen a growing amount of publications and research trying to claim that social media is a very powerful data source in disaster management. But how can we use the information in there? Yes, we can map out the information relevant to disasters, but what are people talking about and why they're useful for disaster response? And last one is how can we remove the bias in social media? In other words, how can we reveal the information expressed on social media from those so-called undervoiced communities and populations. So let's start with the first question here. And if you want to answer the first question, you need to know what kind of disaster-related information are posted and shared on social media. So these are 3 examples in here. Some of the federal agencies and the first responders, they're using social media as a way to communicate, to share the information about what's going on here and what's happening right now. So the first one is posted by the National Weather Service about the upcoming hurricane to a specific area. Not a hurricane, sorry, this is a wildfire. The second one is about people can use social media to update, to report what's going on from a citizen's perspective. So this is an image uploaded during Hurricane Sandy. People talking about the downtown is flooded because of the hurricane. And third one is that people use social media as a communication and a tool to request help and receive the assistance from first responders. So this is information people posted showing like immediate help needed because of a trapped family with address information here. So when we try to analyze the social media information for disaster response or for other disaster related studies, the first thing we need to do is we need to identify whether this message is relevant to disaster or not. And if it is relevant, what specific information is expressed in here. And secondly, we also need to identify the location information. And DBN already gave a very good introduction about the uncertainties of geolocating the social media using the 3 different methods. So sometimes the information can be derived from text directly, for example, the last case, and sometimes we have to use the geotag or other ways to derive the location information. So these are the 2 challenges we need to encounter when we need to solve when we want to make social media data into useful information, location-based information. So in general, there are 3 steps in here when trying to convert the massive, noisy social media data into useful location-based data for spatial analysis or disaster management. The first is a classifier, so we need to classify the information of our interest into different categories. Second one is called toponym recognition. So basically, it's another classification test because within the text, there are text relevant to location and text irrelevant to location. So we need to understand the text information and classify the ones relevant to location information so that we can accurately identify the addresses of different users. And finally, we need to use the toponym resolution, which mostly being accomplished using the commercial or open source APIs or other tools to convert the textual addresses into coordinates. And finally, we can use visualizations and analysis to make the social media use for disaster response happening. And this is actually a 2-step process for either the classifier or the toponym recognition. So considering when we read Twitter data or other messages by ourselves, we actually did 2 kind of like data processing in our mind, which we didn't even notice. The first one is to understand what's being talked about in the message. The second one is to do something like classification, classifying the message into different categories or classifying the words into different, address related or unrelated in here. Unfortunately, because of the deep learning and especially the natural language processing technologies, now we're able to make it happen through computers, and which can help us to identify the message of interest and identify the location information automatically and rapidly. So, okay, thank you. So, for example, with language models like the bird, we're able to understand the human languages more accurately by converting the word into vectors or matrices. And secondly, by using the deep neural networks, we're able to build a classifier based on vectors or matrices into 2 or even more categories. So here is one example and the experiment we did when we tried to classify the social media messages request and rescue on Twitter. We compared the bird-based models. In total, there are about 9 models in here, including one as a baseline model using the GLOB with the transformer classifiers. And we compared the performance using a manually labeled data set. And it turns out the bird with the CNN model yield the best performance with this is the F1 score of over 90% in here. And this is architecture in here. So we first use the bird model to convert the single sentence into the encoded vectors. And later on, we input the vectors into the convolution network and using the softmax to classify messages into different categories. And with this model, we're able to accomplish the first step, converting social media data into different categories. And secondly, we apply another bird-based model to classify the text messages into location-based and location-unrelevant information here. So this time we use a bird with a one-dimensional CNN model and we'll compare the performance of the model, which we call the TOPA bird, with the other 5 existing popular models. And based on precision recall and F1 scores, you can see our model performs much better, significantly better compared to other existing models, with nearly 90% F1 scoring here. So with these 2 models together with the Google API, we're able to make the social media data noisy into something useful and location-based that can be analyzed for disaster response. So for the second question, because of the time limit, I'm going to talk a little bit faster and demonstrate the applications shortly. So the first one is that when we apply the model to identify the rescue request during Hurricane Harvey, and as you can see, a total of 800 rescue requests were extracted in the Houston and the surrounding areas. And later on, we conduct some follow-up analysis, trying to understand where the people request rescue and why they use social media to request rescue rather than through the traditional 911 or other, contacting other first responders. So it turns out many of the rescue requests were sent from the FEMA-defined minimal flood zone, meaning they were unprepared for the flooding because they consider they were in a minimal flood zone, but turns out those areas were also flooded during Hurricane Harvey. And secondly, we find out most of the people who request rescue, the messages were sent out from communities with high, with below average elevation, high receive more rainfall, and also have more socially vulnerable population. Well, this can be interpreted in 2 reasons. Firstly, is because those communities were overlooked in the traditional first responding operations. So it turns out they don't have enough resources, and then they have to use other platforms like social media to request help. And secondly, is because most of them don't have access to internet or social media. So their family members cannot reach out to them. They family members request help for them rather than they request help for themselves. And later on, we realized the use of social media is not only limited to rescue requesting, it can also be applied, the model we developed can be applied to find lost animals, to detect the infrastructure malfunction, or to analyze and extract information about the people or locations offering help or shelters. So we modified and upgraded model, and this is another test we made to understand how people use social media during Hurricane Irma, and different data and different coloring here indicate different types of use of social media, including the one looking humanitarian help requests, the animal help requests, infrastructure damage, as well as the ones providing shelter information. And also later on, we aggregate data into the county level and trying to see if we use the fine-grained the infrastructure damage related information, can we have a better prediction of the damage? And then turns out using the infrastructure related damage information alone, we're able to derive a very accurate estimation of the damage when we compare the number of tweets together with the number of claims issued to by the insurance companies. But wait a second, think about the biases and the people who are not using social media. They're basically overlooked in this analysis. So the third question is, how can we remove the bias in here? Let's suppose there's one person requesting rescue from the circled area in here, and the rest of the households have no people request rescue online. That doesn't mean the people in those households do not need help. Actually, maybe they need help, but they just didn't post the rescue request on social media. So in this way, we incorporate the unbiased remote sensing data, and in this case, with Microsoft Building Footprint data, and together with elevation data to predict the areas, households needing help or being damaged, but not reflected on the social media in here. And these are the three conclusions from this single study. So we found out this method works pretty well, and also reveal some of the so-called overlooked communities, meaning based on the official report, there's no damage, but based on the social media activities, there are people needing help, and also the people reporting the malfunctioning infrastructures in here. Another one is about the demographic bias. So I'm not sure how many of you attended the Pingin's talk yesterday. So this is the demographics of social media users as well as the demographics of the general population. As we can see, many of the population and social groups were overlooked or underrepresented on social media. So what we can do is that we can use deep learning methods to classify the social media users into different user groups by gender and by the age groups. And later on, we can differentiate the reactions of those users towards different events, especially during disasters. So in here, it showcases the use of the social media during the COVID-19 pandemic and how different users shows very different emotional status. So one very important conclusion in here is that the younger generation are more sensitive toward the COVID-19 pandemic and shows much more negative emotions during the outbreak of this pandemic. So to conclude my presentation today, I think there's way more uncertainties and challenges we need to discuss. But unfortunately, I don't have much time to talk about it. So hopefully in the future, when we analyze the social media data, if we consider some responsibilities, including being responsible to the data we analyze and being responsible to how to share the data to the public, I think we can generate definitely a more resilient future through the spatial thinking. Thank you so much.
Time for 2 questions. Feel free to raise your hand if you have any question. So, and can you help check whether we have questions online?
Oh, sure. Yeah, go ahead.
You said that there are other biases that you could look at, but didn't have time. So can you expand on that a little bit?
So you mean other challenges? And
Yeah.
Yeah, exactly. So for example, there's one challenge I recently think about. It's about the privacy issues. So the way we share social media data online is just posted online. And when you sign up for social media accounts, I don't think anybody will read the agreements, but basically we agree to share the information online, especially like the vulnerable groups we identified. And we actually can get a very accurate home address of those vulnerable groups. For good people and for people with good intentions, we can use it very wisely by sending help. But for those with unfriendly intentions, this is a leak of private information to the public. Another thing is about the very classic geographical challenges, including the modifiable area unit problem and the modifiable temporal unit problem, because most of the studies are trying to aggregate social media data into the administrative scales, like county level or block group level. But considering whether this is correct is another problem, because the way people live are not following the county or the human-defined census tract or block groups. And the way we interact across the space are not limited by the administrative boundaries, human-defined. So how to generate more accurate and reliable spatial unit and the temporal unit for social media analysis is another challenge I think we all should take into consideration in the future. Yeah, these are just 2 examples. I'm happy to share more with you. Yeah.
Great. Thank you very much.
Yeah. Thanks for the question. That's a really important one. Yeah. Dr. Sal.
In the later part of your slides, and you show the demographic information of the
Yeah.
Twitter users. So can you share more information? How do you?
How we derive this demographic information of the? Yeah, thank you. That's a really good question. So previously, we're very concerned about, how we can derive the demographic information. Because if you don't infer the demographic information, turns out if we just aggregate all information to calculate sentiment index, it will overlook certain social group. Like we know the social media users and also the younger generation, those are well educated and living in urban areas. And in this study, we actually use an existing model. It's called the M3 model, and the model was published in 2019. The model used the user profile, including the profile images, the personal descriptions, and other relevant information to make a prediction of the age group and the gender, as well as whether this is a public user or this is a agency user or organizational user. So that's how they derive the information. And what we did is we applied the model to examine every Twitter user who posted geotag information relevant to COVID-19 and conduct a statistical analysis. Okay. Thank you.
Thank you for the presentation. And